This is nitrogen triiodide, a highly unstable pink powder used as a contact explosive.
It's created according to the formula 2NH3 plus 3I2 yields 2NI3 plus 3H2. In this reaction, iodine replaces the hydrogens around the nitrogen because iodine is more reactive than the hydrogen. NI3 is unstable because of the ratio between the atomic radii of N and I. Since iodine atoms have a larger atomic radius than hydrogen, they become highly unstable when attached to nitrogen, as demonstrated by the figure. Hydrogen atoms in ammonia are much smaller than the bonded nitrogen. However, the bonded iodines are larger and thus touch each other while bonded to the much smaller nitrogen. Therefore, any agitation will disturb their delicate balance and eject them from the molecule.
When agitated, nitrogen triiodide breaks down through this formula. 8 nitrogen triiodide hydrated with ammonia yields 5 nitrogen molecules plus 6 ammonium iodide molecules plus 9 iodine gas molecules. The reaction releases iodine gas, which is highly corrosive and should be dispersed immediately. There aren't many applications to the decomposition of nitrogen triiodide because the explosion does not generate much force, and the corrosiveness of the iodine gas repels its use with any long-lasting intended materials. It is also very difficult to transport.
To make NI3, mix iodine and concentrated ammonia using rubber gloves and under a fume hood. Make sure to cover the fume hood with paper towels so it doesn't get stained by the iodine. After waiting for approximately 10 minutes, filter out the remaining powder. Smear the powder on a desired substrate and allow it to dry. Keep any items that potentially touched NI3 and are no longer used in a waste bucket filled with water. Make sure they stay wet. Do not handle the dry powder. Even the agitation of the wind from the fan of the fume hood can set off NI3. However, when wet, NI3 is relatively stable. When dry, the resulting explosion should look something like this. Ow.
Calculate the entropy for the decomposition of nitrogen triiodide given the following values. Plug in the values to their corresponding places in the entropy of formation formula. After simplifying, delta S should equal 1709 joules per Kelvin mole. Calculate the change in enthalpy for the decomposition of nitrogen triiodide given the following values. Plug in the value to their corresponding places in the enthalpy of formation formula. After simplifying, delta H should equal negative 2363.4 kilojoules per mole. Calculate Gibbs free energy for the reaction at standard temperature and pressure. Plug the obtained values into the formula to receive the change in Gibbs free energy value of negative 2872.7, indicating that the reaction is spontaneous. Why do iodide ions replace the hydrogen around the nitrogen? Iodine is higher upon the activity series, meaning it is more reactive, and will replace the hydrogen in an aqueous solution. Calculate how much nitrogen triiodide could be made with 20 grams of iodine crystals. By stoichiometry, 20.7 grams of nitrogen triiodide could be yielded.